Good day, grade 12 learners. Welcome to today's physical sciences lesson. My name is Tandiwe. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. As you know, you can interact with us during the lesson using our WhatsApp number 079 578 2908. We are going to try and respond on your WhatsApp messages. Kindly send your school name as we are going to send your WhatsApp so that we can even make a follow-up on assisting you with whatever question you are going to have. Now, today we are going to look at electrochemical cells. However, we are just going to focus on galvanic cell. So I hope this is going to be a revision because some of you have already done the topic. So we are going to look at a galvanic cell. But before we look at the lesson, we need to look at what we did in grade 10 that will assist us with a pre-knowledge to be assisted in understanding the following topic. So in grade 10, we looked at periodic table. I think the periodic table is always part of our chemistry. And you know that every time when we do a lesson in chemistry, we'll definitely always refer to the periodic table. Now, what is it that is important on the periodic table? As I open the periodic table, and the periodic table is also in front of you, because I will always encourage you to have the periodic table in front of you when we are going to do any lesson in chemistry. So you can see that our periodic table, it is having elements. And in those elements, what do we have? We know that elements are divided into metals and non-metals. Why it is important to understand the properties, or why it is important to go back and look at metals or non-metals. In this lesson, we are going to look at how are ions formed and how can ions go back to form also elements. So we know that we have lots of metals in our periodic table. However, we have very few non-metals. So what you understand about non-metals and metals, we know that from the information that you know about metals and non-metals is that metals can do what? Metals, one of their property is to lose electrons. And also metals are good conductors of electricity. Therefore, as we are reminded about these properties, we will be assisted to know what is it that we have to do always when we have a metal. Therefore, we know that as metals loses electrons, they will form ions. Now, we need to know which ions can be formed by metals. From the periodic table, we know that we have groups like group number 1, group number 2. We can exclude the transition metals and look at 3, 4, 5, 6, 7. We know that group number 8 elements do not react. Therefore, we need not to put them as part of the atoms or elements that will react. Now, we know that elements can react according to their group number because the trend in which they are reacting or the trend in which they are bonding, it depends on which group they are. Therefore, like when you see elements in group number 1, you will know that these metals, only one non-metal in group number 1, which is hydrogen. However, all elements in group number 1 are metals. Therefore, what is the property of the elements in group number 1? Elements in group number 1, they will lose 1 electron as metals. So it means they will lose 1 electron. Therefore, when they lose 1 electron, what will they become? They will become ions. For example, lithium is one of the elements in group number 1. Therefore, it means lithium as a neutral atom, when it loses an electron, is going to form lithium ion plus electron. So therefore, we know already that this is an ion of lithium. The +1 is an indication that it has lost 1 electron, meaning that it has more 1 proton than electrons. I think that is the most even clarified definition to say, why do we say it's +1? We know that if you look at the number of protons and electrons after it has lost or shared or transferred an electron, it is going to have 1 extra proton than electron. So that is why its charge is 1. If you look at calcium, calcium is in group number 2 and it's also a metal. If it loses, it's going to lose now 2 electrons and form calcium 2 plus ion. Therefore, we already know that if you look at all these metals that I just referred to, you can see that as they lose electrons, they form positive ions. And we know that when you look at different types of ions, we have two types of ions, which are cations or cations and anions or anions. Therefore, when you look at the metals, the way they lose electrons, they mostly form cations or cations, meaning that they will lose. And when they lose, as we understand the losing of electrons, we know that they definitely their oxidation numbers will change, which is something that we also did in grade 11 and we are going to look at. Lithium started being 0 as the neutral atom, where it was having equal number of electrons and protons. Immediately when it loses electrons, it will now become +1. So it means the oxidation number of lithium increased, meaning that it has moved up. Immediately when an element loses electron, its oxidation number will increase. Even in calcium, it started being 0 and then it went to 2+. So its oxidation number, so immediately when it is charged, immediately when it becomes an ion, its oxidation number changes. And we look at whether the oxidation number change in terms of decreasing or increasing. But you can see that the more a substance loses an electron, its oxidation number increases. Meaning now that if we want to go back to calcium as a neutral atom or as a neutral element, this calcium 2+ ion must gain the 2 electrons that it has lost to go back. Therefore, immediately when it gains electrons, you will see that now its oxidation number will decrease. How does it decrease? It is moving from 2+ to 0, showing that the gain of electrons will make the oxidation number to decrease, which is what we got from the periodic table. So that is why I said always refer to the periodic table, look at the trends of this element, look at the properties of this element, so that you can see and you can also understand why positive ions are formed or why negative ions are formed. When you look at oxygen, oxygen is one of the nonmetals. So what does it do? It gains electrons. Immediately when it gains electrons, it forms a negative ion, an oxide ion. So you can see that now oxygen, because it's a non-metal, it can be able, even chlorine, it can also be able to, I think we understand now why do I write oxygen as O2 and chlorine as Cl2, because they are diatomic elements, which are the 7, which are form part of the 7 diatomic elements, whereby they exist as diatomic in nature. Therefore, this one will form a chloride ion. So I think we understand, if we balance, we can put 2 here. So I think we can understand that now these elements, they will lose or gain electrons to form ions. So these ones, as they are gaining electrons, they form negative ions. And we agree that negative ions are referred to as anions. Therefore, a chloride ion is an anion, an oxide ion is an anion. So for a chloride ion to go back to form chlorine, so you can see that it started being as 0, and then when it gains electron, it becomes -1. And when you look at from 0 to -1, you can see that there is a decrease in oxidation number. So the decrease in oxidation number caused by the gaining of electrons by that specific element. Therefore, it means when you go from being 0 to -1, the oxidation number decreases. However, if you want to go back to the original element, you are now gonna lose the electrons that you've gained as a chloride ion or as an oxide ion or as an anion, so that you form what? You form the original element. So in this case, a chloride ion will lose the electrons that it has already gained and go back to chlorine gas. And in that case, now the oxidation number will start to increase again. But when it gains electrons, the oxidation number, we've seen it has decreased. Now, it is also very important to understand the ions in solutions. As we are going to deal with ions, as we are going to deal with solutions that contains ions, those solutions that we are going to deal with, they are containing both anions and cations. Therefore, when you can be able to identify ions in a solution, you can also be able to understand how does those ions react. Therefore, the ions in aqueous solutions are very important. Like if you are given a compound like aluminium oxide, you will know that in aluminium oxide we have aluminium ion plus oxide ion. Therefore, as they combine together, they are going to give us aluminium. So this identification of ions in a compound or in an ionic solution will assist us also to know whether the oxidation number of a specific element or species has increased or has decreased. So always it is very important to remember this. I already talked about cations and anions, and I already showed you this compound aluminum oxide, whereby we know that this one is going to be our cation and this one is going to be our anion. Therefore, it is very important also to remember what you have done previously in grade 10 in terms of identifying ions in a compound, so that you know which positive ions are formed. And in writing the compound, we know that we always start with the cations and follow with the anions, or we write the positive ions first and follow with the negative ions after. That is why when we write aluminum ion oxide, we will start with Al, because it forms a positive ion, which is an Al3 plus, and O2 minus, which is our oxide. Therefore, we must definitely go back and look at those ions and also be able to identify them in a compound. Balancing of equations is very important for every reaction that undergoes chemical change. We know that we deal with the constant composition of matter. There is no way that at the end of the day we can say we don't know what happened to an element in terms of the numbers, as we look from the side of the reactants and the side of the product. Therefore, we definitely always have to make sure that our reactions are balanced whenever we are undergoing a chemical reaction. And then types of reactions. We just did a acid-base reaction in our previous lesson. And when we're looking at acid and bases, we look at proton transfer. Now, as we know that acid and bases deal with proton transfer, now we are going to look at another type of reaction. So redox reactions or galvanic reactions, they undergo a different type of reaction as compared to the previous one that we did. So it is very important to also remember the types of reaction that we did previously. Therefore, the next thing that you need to remember, I already introduced the issue of oxidation numbers. So it means if we are going to look at oxidation numbers, we will know that an element or a species has undergone a transfer or the loss or the gain of electrons by looking at whether the oxidation number of that substance has changed. So if the oxidation number changes, it shows that it's either you have gained or you have lost electrons. Therefore, we will always refer to it and check whether the oxidation number has changed. But what is also important is to know the oxidation numbers and is to assign the oxidation numbers. So there are rules that we use to assign oxidation numbers. And those rules, we discussed them last year in grade 11, whereby we look at how does oxidation numbers of different substances work. Like we know that, for example, we know that all elements, let me just start by saying all elements in the periodic table, all free elements in the periodic table, their oxidation number is 0. So immediately when I take an element from the periodic table, the way it appears in the periodic table, I will already know that their oxidation number is 0, meaning that they are neutral. By neutral, I mean they have same number of electrons and protons, and including those diatomic elements. Those diatomic elements are what? Are iodine, are bromine, chlorine, nitrogen, hydrogen, fluorine, and 3, 4, 5, 6, 7, and what? Oxygen. So we already know that all these diatomic elements, their oxidation number is also 0. So therefore, whenever you see O2, you already know that it's a neutral atom. And all the compounds like water, like aluminum oxide that I just gave example, they have oxidation number which is 0. Immediately but within the oxidation number, you can still identify the oxidation number of each element or atom. Therefore, it is very important to understand that if you're having a compound, the oxidation number will be 0. So in this table or in these rules, they are telling you how is the oxidation number of different atoms or ions and how do you assign the oxidation number, which is not what we are going to discuss today, but definitely your teachers can give you these rules on how to assign oxidation number, especially in cases whereby now we know that we have things like a peroxide. What is the oxidation number of oxygen in a peroxide? And also, what is the oxidation number of oxygen in when there is hydrogen and oxygen and chlorine in that specific formula? So we will look at that, but also we know that the oxidation numbers will also sometimes depend in a group where the element is found. Like all the oxidation numbers of elements in group number 1, A there is plus 1, in group 2, A is plus 2. So that is why calcium is Ca2, but hydrogen is H plus, because it depends on the group in which that specific element is in. The reason why we go back and try to check in terms of the previous knowledge that we have about the topic is to assist us to see whether the reactions that we are going to talk about today, they've taken place or not. So that will only be seen by the change in oxidation numbers, because these elements can lose or gain electrons and form ions, or they can form metals. Now, what is it that the lesson will be all about? I know we don't have enough time to explain everything, but whatever that we are going to explain will try and assist us to revise on what we have already done with our teacher. So we are going to define a galvanic cell, and we are going to define also oxidation and reduction in terms of electron transfer and also in terms of oxidation numbers. Now, you need to understand that the exam guideline will always give you what is expected out of you by the end of the lesson. Therefore, whatever that I'm now listing is what is stipulated on your exam guideline, and it is what the examiner will expect you to know at the end of the lesson. We will also define the oxidizing and the reducing agent in terms of oxidation and reduction. We'll also look at the anode and the cathode in terms of oxidation and reduction, and we'll also define an electrolyte. This is the bullet according to the exam guideline. So they are taken directly from the exam guideline. We are going to state the potential difference of a galvanic cell as the V cell, which is related to the extent to which the spontaneous of the cell reaction has reached equilibrium. And we are also going to look at how will the value of the V cell be affected by the concentration of the product ions and the reactant ions as they are going to be formed during this reaction of reduction and oxidation. We will talk about the movement of ions, we'll talk about the direction flow of electrons, and we'll also talk about the reactions that occurs in the half cells, which are electrode half cells, whereby we are going to look at what half reactions occur in each electrode, and also talk about the function of the salt pressure. So what I'm currently doing, I'm just stating the objectives of the lesson. We'll also use the cell notation or diagram to represent a galvanic cell, and also on how do we write our cell notation. And also we are going to explain what do you mean by inert electrodes, and then predict the half cell where oxidation and reduction will occur, and also be able to write an overall reaction using also the standard reduction potential table to calculate the EMF is what we are going to look at, and also explain the meaning of the positive value in order to indicate whether the reaction is spontaneous under standard conditions. And then we are also going to use the electrode, which is called hydrogen electrode, as our reference electrode. Why hydrogen electrode is referred to as a reference electrode, and explain how the standard electrode potentials can be determined by using that reference electrode. Now, as we are going to start our lesson by looking at each and every bullet. So we'll try and explain each and every bullet according to the exam guideline and according to the way it is stipulated. So the first thing, we need to define galvanic cell. So how do we define a galvanic cell? A galvanic cell is a cell that converts chemical energy to electrical energy. I know there is always a close relationship between whatever definitions that we did previously, also in physics, and what we are doing now in chemistry. But remember, in chemistry, we are dealing with chemicals, we are dealing with chemical energy. Therefore, we will definitely know that is the conversion of chemical energy to electrical energy. It is very important that the wave energy form part of your definition, because that is the energy conversion, that is the energy that is converted. We will also know that these galvanic cells are spontaneous cells. They undergo spontaneous reaction. What do you mean by spontaneous reaction? The reaction occurs on its own, meaning that we don't need to add energy for these reactions to occur. So they occur on their own spontaneously. And also, as we are going to form electrical energy at the end of each reaction, we will say also these are exothermic reactions, meaning that energy is liberated or given off as electrical energy. So energy is formed during this electrical energy. So energy is formed during these reactions of galvanic. So it is very important to know the definition and to understand that they occur on their own, and also to understand that they give off energy in a form of electrical energy. Now we are going to look at these reactions. These reactions, now they are all about electron transfer. We call them redox reaction. Redox reaction is about taking away electrons and accepting electrons. As I said that there will always be different types of reactions that we deal with. In terms of SN basis, we're dealing with proton transfer. Now, in terms of this redox reaction, we are going to look at electron transfer. Now, what do we mean by redox? Redox is just an acronym that indicates a reduction and oxidation reaction. So in one, or if you combine the two, because these reactions occur simultaneously, the other one causes the other one to occur. So therefore, we normally say they are all one and they occur simultaneously. So these redox reactions are electron transfer, and as I said that our electrons are easily transferred or are easily lost by metals. Therefore, we already know that the reason why metals can lose this electron is because of being good conductors of electricity. Now, we need to define the oxidation and reduction reactions. And there are two ways that are stipulated by the exam guideline in terms of defining the two terms. So we are going to look at in terms of electron transfer and also in terms of oxidation numbers. So what does reduction and oxidation say in terms of electron transfer? In terms of electron transfer, oxidation is the loss of electrons and reduction is the gain of electrons. Therefore, it means we are expected to know how do we define the two terms in terms of either electron transfer or oxidation numbers. And the examiner will ask you in which terms do they want you to define. Now we can use things like oil rig, whereby we say oxidation is loss of electrons and reduction is gain of electrons. So this oil rig can also assist us to remember, because there are lots of terms that we are dealing with and there are lots of definitions that we are dealing with. Therefore, when you use things like oil rig or LEOGAIR, where we say loss of electrons is oxidation and gain of electrons is reduction. So we can also be assisted just to remember how do we define oxidation and reduction in terms of electron transfer. Then in terms of oxidation number, when we see an oxidation number of a substance increases, like for example, if you see lithium forming lithium ion plus electron, we can see the oxidation number moves from 0 to 1. Already we can say lithium as the metal has undergone oxidation because its oxidation number has increased. However, if you see lithium ion gaining that electron that it has lost and go back to lithium from 1 to 0, we can say, so this can be an example of oxidation and this can be an example of reduction in terms of the oxidation numbers. Therefore, you always check in which terms do you need to explain your oxidation or your reduction. Now we are going to look at two substances reacting with one another. And during that reaction, one substance will be losing electrons, whereas the other one will be gaining. Now what you need to understand is that a substance that loses an electron, it is made to lose an electron by the one that will be gaining that electron. Therefore, we refer to these substances as agents. And what we need to understand is that our agents, they are our reactants. So these are the substances that made the reaction to be possible, meaning that before we have agents, we won't have any reaction. Therefore, we need to firstly have our agents. But what I'm saying about the two agents that will be reacting with each other, I'm saying the one agent will lose electrons, whereas the other one will gain electrons. Now, the one that loses electrons will be undergoing what? Oxidation. And the one that will be gaining electrons will be undergoing reduction. Therefore, it means now for me to undergo oxidation, something has caused me to undergo that oxidation. Therefore, what is the substance that is causing oxidation? Definitely, a substance that will cause oxidation will definitely not undergo oxidation, but will cause the other substance to undergo oxidation. Therefore, it means now for me to undergo oxidation, I am caused by an oxidizing agent. So what is an oxidizing agent? It's an agent that causes oxidation. However, an oxidizing agent will not undergo oxidation, meaning it will make the other substance to lose electrons. So we say it's an oxidizing agent. But what does the oxidizing agent will undergoes as it causes oxidation? Oxidizing agent will undergo reduction. So it means it's a substance that gains electrons. We know electrons can only be gained during reduction. Therefore, it means our oxidizing agent will undergo reduction reaction by gaining electrons. And after gaining electrons, its oxidation number will decrease and that agent will be reduced. So you need not to confuse yourself thinking that oxidizing agent will undergo oxidation. Definitely not. An oxidizing agent will cause oxidation. However, an oxidizing agent will undergo reduction. And how does the oxidizing agent undergo reduction? It will only undergo reduction by doing what? By gaining the electrons. And when it gains electrons, its oxidation number will do what? Will decrease. I think we have already explained what we mean by the increase in oxidation number and what we mean by the decrease in oxidation number. Therefore, the oxidizing agent will gain electrons and be reduced. However, the reducing agent which causes reduction will undergo oxidation, meaning that now the substance that loses those electrons will be our reducing agent. And at the end of the day, our reducing agent will be oxidized. So the reducing agent will cause what? Reduction. However, the reducing agent do what? Undergoes oxidation. So why am I explaining this time and again? Because the agents seem to confuse the reactions. But remember, the agents are the ones that make the reactions to be possible. So if I'm saying I'm a reducing agent, it means I am causing the other substance to be reduced. And when I'm saying I'm causing the other substance to be reduced, it means I am causing the other substance to undergo reduction so that at the end of the day, that substance can be reduced. Therefore, if I'm an agent, I will definitely make the reaction to be possible to another substance. Therefore, an oxidizing agent gains electrons and undergoes reduction. A reducing agent loses electrons and undergoes oxidation. Then by being oxidized, so it is very important to know that you are being oxidized from where to where. Like for example, if I'm saying lithium will lose electrons, it means lithium is my oxidizing agent. Therefore, it will lose electrons and become lithium ion and electron. So it means lithium will be oxidized from lithium atom or solid to lithium ion. Therefore, when you are saying you are being reduced, you must also know how are you being reduced, from where to where. That is a very correct scientific way of explaining these agents. To say if you are undergoing oxidation, what will you become on the side of the product? Because as I explained that our agents will always be found on the side of the reactants. Now we are having electrodes. Electrodes in a galvanic cell will be our terminals. Remember, this is a cell. For every cell to function, we need to have a positive and a negative terminal so that electrons can flow from one side to another. Therefore, our electrodes now in this regard, they are going to be used as our terminals. What are these electrodes? These are solid electrical conductors. It is very important to know that immediately when you say an electrode, you know that first thing it must be a solid, and secondly it must be an electric conductor. Therefore, it means all the reactions must definitely have the electrodes that will become their terminals at the end of the day, so that those electrodes can be able to conduct electricity. Now there are two types of electrodes that we have, anode and the other one is cathode. So we need to know what type of reaction occurs in each electrode. Remember, we are going to make two reactions occur at the same time, whereby we are going to have the one losing electrons and the other one gaining electrons. Therefore, if we are having the electrodes, it means one electrode will be found where oxidation will occur and the other one will be found where reduction will occur. Therefore, in terms of an anode, which is one of the electrode that we are going to have, at the anode we are going to find oxidation. So at the anode is where oxidation will occur. When I say at the anode is where oxidation will occur, it is because the anode can be able to undergo electron loss, or sometimes you will find that your anode is there but it cannot lose electrons. Therefore, it is very important when I say where instead of that, because when I say where, it means it there where oxidation will occur. And therefore, where oxidation will occur, we are going to find our anode. And we can use the acronym like OXAN, where we say oxidation occurs at the anode. So you will find our anode and you'll know that we expect oxidation to occur. And therefore, it means now our reduction will occur at the anode. And we can use things like REDCAT, even though I'm not sure whether the REDCAT do exist. But we can use REDCAT to say reduction occurs at the cathode. Therefore, these are our anodes and cathodes, and these are referred to as our electrodes. And they are solids and they are good conductors of electricity. So they will definitely allow the movement of electrons, or they will definitely allow the movement of ions or of electrons as charges from one side of the reaction to the other side of the reaction. So remember which type of reaction occurs in which type of an electrode. Just for revision, we can know that at the anode, that's where we are going to find our reducing agent, because remember our reducing agent undergo oxidation, and that agent at the end of the day will be oxidized. At the cathode electrode, that's where we are going to find our oxidizing agent, which will undergo reaction and is going to be reduced by the end of the reaction. Now, as we are going to convert chemical energy to electrical energy, where is that chemical energy going to come from? Our chemical energy is going to come from our electrolytes. Our electrolytes, as they are having those ions as compounds, they are going to convert that ionic energy, that energy which is the chemical energy, to electrical energy. So what is this electrolyte? Electrolyte is a substance of which the aqueous solution contains ions. So the word electrode and electrolyte can be very close to each other, can be very close, like similar, but you need to know and you need to differentiate between the two terms, because electrodes, they are solids and they are good conductors of electricity, but electrolytes, they are solutions and they also conduct electricity in a solution form, whereby these ions will be the ones that will be conducting that electricity. That is why they are saying another way of explaining an electrolyte is a substance that dissolves in water to give solution that can conduct electricity. So you need to be able to differentiate between an electrode and an electrolyte. Electrolyte as a solution, electrode as a solid. Then, how do we then identify a galvanic cell? As we know that we are going to deal with two types of cells under electrochemical cells. Now we need to identify the two cells and we need to know the difference between the two cells. Then how do we see a galvanic cell? A galvanic cell will be seen by having two electrolytes. We have already defined an electrolyte. We have already seen how is an electrolyte formed. An electrolyte is formed by two types of ions, which are positive ions and negative ions, cation ions and anions. Therefore, these electrolytes will be separated by a Soule bridge. So immediately when you have a Soule bridge and two electrolytes, and how do we see electrolytes? Electrolytes can be seen by having two different ions in a reaction. Like for example, if we are having a reaction where we have Zn plus Cu2 plus, giving you Zn2 plus, just giving this example, plus Cu, you can see that there are two different ions. There are two different ions in this reaction. Therefore, we can immediately say this is an example of a galvanic cell, because immediately when you have two electrolytes in a reaction, it means that reaction is representing what? A galvanic cell. And the electrodes are connected to a galvanometer or a voltmeter via an external circuit. So immediately when we say we are going to have an external circuit, it means there is also an internal circuit. And then we also have a salt bridge that consists of a salt. I think by now we already know what is a salt. We have formed different salts during our acid-base reactions, and we have seen how salts are formed, and some of the salts being acidic, some of the salts being basic. But we know that if you're having a salt like sodium chloride, we know that there are two ions involved, Na plus and Cl minus. So in our salt, we need to have both positive and negative ions. Sometimes if we replace our salt bridge or our salt with a substance that is not a salt like sugar, we cannot expect electrons to be formed in that reaction. Therefore, we definitely need to have a salt and a soluble salt for us to form a salt bridge so that it allows the movement of ions between the half cells. Now, in a galvanic cell, we will have the building of a galvanic cell. And how is the galvanic cell built? We're going to have our two half cells, whereby we have two electrolytes, and each half cell representing oxidation and the other one representing what? Reduction. So in our half cells, we are going to have an electrode that is representing an anode. Now, an anode will be our negative electrode. Remember, in a galvanic cell, we don't have any connection of any cell. The cells becomes positive and the cells becomes negative according to the way the reactions will occur. Therefore, we are having an anode which will be our negative electrode, and that is where oxidation will occur. And think about it. If we are having an electrode and we are seeing that electrons are moving away from that electrode, you can immediately think about electrons being repelled by that electron. And immediately when you say the electrons are being repelled, you can conclude to say they can only be repelled if that specific substance or that specific electrode is negatively charged. Therefore, our cathode will be our positive electrode where reduction will occur. So, as we are not going to confuse the two cells of electrolytic and galvanic, we know that in a galvanic we don't have any source, or we don't have any power source that will provide energy. These electrodes will definitely become positive and become negative according to the way they react. Now, we are saying we are going to have two half cells, which the other one undergo reduction and the other one undergoing oxidation. Now, what are we going to use to see which half cell will undergo oxidation and which half cell will undergo reduction? We are having our standard reduction potential table. Our standard reduction potential table is going to be provided to us as one of the documents as data sheet. Therefore, it means it is very important to know what is this a table all about. For the purpose of this lesson and for the purpose of understanding what we are going to talk about, there are two cells, and the other one is 4A and the other one is written 4B. So in this case, we are going to use our 4B. What do you do when you get into the exam room, getting the two tables? Because our lesson, as I'm doing it today, it is mostly focused on 4B. Definitely the two tables are the same, but they are just vice versa. So when you look at table 4B, you will see that when you have two arrows, the other one going up and the other one going down. In this one, it says this is the increase, it's written increase in reducing agent. And then when you look at this one also says increase in oxidizing agent. So when you go down from this side, you will find that your oxidizing agents are increasing. But when you go up from this side, you'll find that your reducing agents are increasing. Where are the reducing agents? Our reducing agents are written on this side of the table, and our oxidizing agents are written on this side of the table. So this side represents our oxidizing agents, whereas this side represents our reducing agents. How are these agents compared? Because it is very important to understand the strength of this agent, because the two arrows are indicating how does the strength of the oxidizing and the strength of the reducing changes. So when you look at lithium, lithium is at the top, meaning that as you go up, you know that the strength of the reducing increases. So it means lithium is the best reducing agent. What do you mean by the best reducing agent? We mean that as you compare lithium with other reducing agents this side, you will find that lithium can lose electrons faster than any other reducing agent that you see here. So let's say we compare lithium and magnesium, or lithium and barium. You will find that lithium is the stronger reducing agent than barium. But barium can also be a stronger reducing agent than magnesium. So the more you go down from the lithium reducing agent, when you're going down, the strength of reducing ability decreases. But when you go up, the strength of the reducing ability increases. Meaning lithium is the best reducing agent. But when you go from lithium ion going down, you can see that the strength of oxidizing increases. So lithium ion can be the weakest what oxidizing agent, whereas lithium is the strongest. So if the agent is a stronger reducing agent, it will have a weaker oxidizing agent. When you go down, my table, I divided it into two. When you go down, you'll find fluorine at the bottom of the table, and fluorine is on the side of the oxidizing agent. Therefore, it means fluorine is the strongest oxidizing agent as compared to all the oxidizing agents that I just indicated. Whereas the fluoride ion will be our weakest reducing agent. Remember, the reducing agents, we read them this side, and our oxidizing agents, we read them this side. So as we're going to compare the strength, if you compare the strength of reducing agents, you just have to compare the strength of the reducing agents only. And if you compare the strength of the oxidizing agent, you just have to compare the strength of the oxidizing agent only, because the strength of reducing and oxidizing represent on whether that specific species will gain faster than the other one or will lose faster than the other one. Therefore, it is very important that, let me just go up to say, if we compare a lithium half cell, let's take lithium half cell, and we compare it with a magnesium, let me just take this one, the cesium half cell, we'll see that now lithium will be a stronger reducing agent than this cesium. Therefore, it means in terms of oxidizing, in terms of reducing ability, in terms of losing of electrons, lithium will lose electrons faster than that other one and form lithium ion, which is going to be our aqueous solution plus electrons. But when you look at the ones that you're comparing it with cesium, it means now as lithium is losing electrons, therefore our cesium ion will gain those electrons and form what? And form cesium. I'm just showing this reactions on how are these oxidation reduction gonna occur. But the most important is, how do we write them after identifying which one will undergo oxidation and which one will undergo reduction? We normally say we write them as C, meaning that the oxidation will start from the side of the reducing agent and the reduction will start from the side of the oxidizing agent. As we know that this, we indicated to it as our oxidizing agent according to our table, then this one will be our reducing agent. And what happens to the oxidation numbers of our agents? You can see that lithium move from 0 to +1. It means the oxidation number is increased. But cesium move from +1 to 0, meaning that the oxidation number is decreased. But whose oxidation number has increased and whose oxidation number is decreased? The oxidation number that it has increased is for the lithium. The oxidation number that it has increased is for the cesium. So therefore, you need to know what oxidation number has decreased. So if you look at the two, you can immediately know that the other one will undergo reduction and the other one will undergo oxidation. But what will assist you? The table will assist you in terms of the comparing of the strength of the reducing and the oxidizing ability. So as we are looking at this table, we are just going to take a 2 minutes break just to think about how do we choose the oxidation and the reduction half reaction. So when we come back after our short break, we are going to look at how then do we write our oxidation and our reduction reaction if we are provided with the reactions of different half cells. So our 2 minutes short break will start now, and after that we'll look at how or when do we choose a half cell which will undergo oxidation and the other one which will undergo reduction. Okay, welcome back, grade 12s. I think we have just tried to explain how is our table going to be used. I already explained which side do we read our reducing agents and which side do we read our oxidizing agents. Now we need to know how do we write our half reactions. As I said, that we are going to write our half reactions. Normally we use the format of starting with the oxidation reaction, and then after that we write the reduction reaction. Therefore, first thing that we are going to do, we are going to compare our strength of the reducing ability or the strength of the oxidizing ability. Now, if we look at calcium and magnesium half cells, we can see that when we look at their cell potential also, calcium will have more cell potential than magnesium in terms of the numbers. Therefore, we are going to say between the two half cells, which one is a stronger or has a stronger reducing agent. So therefore, if you look at the cell potential, you can see that calcium will give more cell potential than magnesium. Therefore, calcium will undergo oxidation, whereas the magnesium half cell will undergo reduction. So therefore, how do you write our half cells? We will start by our reducing agent, which is calcium solid, giving us what? Calcium 2 plus, which is going to be in aqueous solution because now it's in a form of ions, plus 2 electrons. And therefore, this will represent our what? Our oxidation reaction. And then magnesium 2 plus will gain the 2 electrons that are coming from calcium and will form what? Magnesium, which is our metal or solid. Therefore, we'll always start from our reducing agent, and then after that, we go from the reduction, we start it from our oxidizing agent. Why do we start from the reducing agent? Remember, our agents are our reactants. So what do we mean? What do we say in terms of reading this reaction? We are just saying calcium as a metal will lose electrons because it's in group number 2 and can lose 2 electrons. And these electrons that it will lose, they will definitely not be lost and not go anywhere. They will do what? They will be accepted by the magnesium ion, which is going to be our oxidizing agent. Therefore, if we think about this reaction, it means calcium is losing electrons, and who's gaining those electrons is magnesium 2 plus ion. Therefore, if we want to write an overall reaction, we combine the two. Remember, we said there are half reactions. So half plus half make 1. So for us to write an overall reaction, it means we're going to add the two reactions by saying it means calcium as a solid will lose electrons and give to who? Because we're going to cancel out the electrons because we are adding now. As we are adding, the electrons will cancel out. So it will give them to magnesium 2 plus, which is our aqueous, to form what? To form calcium 2 plus aqueous, plus what? Plus Mg solid. So this is our overall reaction, meaning that now we know if one substance loses electrons, where will those electrons go? So this calcium and magnesium, they are our agents. The other one is a reducing agent, the other one is an oxidizing agent. We can identify our reducing agent by using the table, or we can also identify them by looking at the change in the oxidation numbers. We know that the agent in which its oxidation number increases will undergo oxidation. The one in which oxidation number decreases will undergo reduction. However, when you look at calcium, you can see that calcium is on the side of the reducing agent. Magnesium 2 plus, here it is on the side of the oxidizing agent. So you can also use the table after writing your overall reaction to check whether that species or that substance is an oxidizing or is a reducing agent. So our reactants now, it means our calcium is going to be our reducing agent. And what type of reaction will it undergo? It will undergo oxidation reaction. Our magnesium is our oxidizing agent, as we have identified it on the table. And it will undergo what? Reduction reaction. So as these agents are reacting with one another, the other one loses, the other one gains. So we can also say calcium moved from 0 to 2 plus. So its oxidation number is increased to indicate that it has undergone oxidation. Mg2 plus moving from 2 plus to 0, also indicating that there was a reduction. Magnesium 2 plus ion has been reduced to magnesium. Calcium solid has been oxidized to calcium ion. That is very important that you know from where to where, starting from the side of the reactants to the side of the product, saying how was the change in the oxidation number of that specific. And we can see that we have cancelled out our electrons. Sometimes you'll find that the way, like when we take calcium and aluminium, as they are very close to each other, the way these electrons are shared, they are not equal. Like if you take the example of calcium and aluminium, the first thing we check which one between aluminium and calcium is the stronger reducing agent, and that one will undergo oxidation, and the rest, the half reaction of the other one, will undergo reduction. As we said that electrons are being lost by metals, there is no way that magnesium or calcium can donate electrons and be accepted by magnesium. Remember, magnesium is also a reducing agent. Magnesium also wants to lose electrons. Therefore, if calcium loses electrons, it cannot give it to magnesium, but what will it do? It will give it to magnesium ions, as they are already in a state of losing. They've already lost. For them to become Mg2 plus, it means there are already 2 electrons that are being lost by this ion, by this metal. Therefore, the magnesium ion is the one that will gain those electrons that are coming from calcium. So you need to know where are the electrons going, who will accept the electrons that are coming from the oxidation side. So this one is about magnesium aluminum. So we can see that magnesium solid, in this case now, it is undergoing oxidation and giving us magnesium 2 plus aqueous plus 2 electrons. Even though both magnesium and aluminium are weaker than lithium, because lithium is the strongest, but there is still a comparison in the reducing ability as you go up or down between the two. So you know that magnesium is going to be weaker than lithium, but it's stronger than aluminium. So that is why magnesium is undergo. And it was weaker than calcium, because calcium, when it was reacting with magnesium, magnesium cannot lose electrons before calcium. So you can also compare the strength within the weak, because the strongest is lithium, but still the magnesium and the calcium and the aluminum, you can also be able to compare them. So it means now our aluminum ion will do what? Will gain the electrons and give us what? Our aluminum as our solid. Remember, this is in a ionic form, is aqueous. So you can see that the way the magnesium is providing electrons is not the way the aluminum wants to accept those electrons, because aluminum needs to accept 3, whereas magnesium is providing 2. That's why now we say we need to balance our electrons, so that as they are being shared by the magnesium to aluminum, they are shared in a way that they are sufficient. So we need to balance our equation. So how are we going to balance? Magnesium is having 2, calcium is the aluminum is having 3. So we'll just take the 3 of aluminum and multiply magnesium half cell, and take the 2 here and multiply aluminum, meaning that it's gonna be now 3 Mg solid, giving us 3 Mg2 plus 6 electrons, and then the other one is gonna be 2 aluminum, giving us what? Plus 6 electrons, giving us 2 aluminum solid. So what we're gonna do now, we are trying to balance our equations to say now there are 3 magnesium solid to give us 3 Mg2 plus aqueous plus 6 electrons, and then aluminum is 2 aluminum ions plus 6 electrons, giving us what? 2 aluminum solid. This one is aqueous. I just like to write the phases so that we can be assisted. So the number of electrons are now equal. So the net reaction is going to be 3 Mg solid plus 2 Al, 3 plus aqueous, giving us 3 Mg2 plus aqueous plus 2 Al solid. So immediately when you write this, it means now you have written your balanced overall reaction. Therefore, you know that for this you will get 1 mark for the reactant, 1 mark for the product, and 1 mark for balancing your reaction. The easy way, you just change the electrons. The other one you multiply the top one, the other number of electrons you multiply the bottom one. So that is how we balance our reaction. So if we have a example of a galvanic cell like this one of zinc copper, zinc copper cell, we will firstly look at zinc and copper, and now start and compare their reducing ability. And definitely, if you look at the table that we just talked about above, you will see that zinc is somewhere here, and above zinc there is no copper. It means copper will be below, showing that now if this is copper, where is copper? Here is copper. So it means now our copper will be our weaker reducing agent. Therefore, it means zinc will undergo oxidation, whereas the copper half cell will undergo reduction. So it means our oxidation will be undergone by zinc, giving us Zn2 plus 2 electrons, and then the copper half cell will undergo reduction and give us what? Copper. Now we are going to explain exactly what is happening in each half cell, because we need to understand how is zinc losing electrons and forming zinc 2 plus, and how copper 2 plus is gaining those electrons coming from zinc. So I'm going to use this zinc half cell to explain exactly what is happening between the two half cells. Now let's look at the first half cell, which is the zinc half cell. Let me just try to make it a little bit bigger. We know that we are going to have our zinc electrode, and we are going to have our electrolyte. Remember, the electrolyte must also contain the ion of that electrode, like zinc sulfate in this regard. So in zinc sulfate, we have Zn2 plus ions and SO4 2 minus ions. Zn2 plus and SO4 2 minus. So because it's a neutral electrolyte, it will have the same number of positive ions and the same number of negative ions. So what will happen immediately when the cell starts to operate? Let's now look at the site of zinc. At the site of zinc, this is what is going to happen. Zinc electrode, because now is the one that is going to lose electrons, as it is the one that is being oxidized to zinc ions according to the half cell. It means zinc will now dissolve into this solution of zinc sulfate and provide zinc 2 plus ions into the solution. And immediately when it does that, the zinc electrode will now start to lose mass, meaning that now the zinc electrode will decrease in mass. Let me just use the word decrease in mass. So the mass of zinc will decrease. The reason why the mass of zinc is decreasing is because as the zinc electrode is losing electrons, its ions, the zinc ions, are forming and they're going into the solution, making the zinc electrode to decrease in mass as the electrons are being formed and they are moving away from the zinc electrode. Now, this side now of the zinc capsule, it is having now more positive ions than the negative ions. So it means now this side of the zinc electrode, it is now more positive. What caused this side to be more positive is because of the zinc ions that are coming into the solutions as the electrons are moving out of them. So that is why the zinc electrode now is becoming negative, because there are some of the electrons that are still on top of the zinc electrode as the electrons are being repelled away from the zinc electrode. So they will also give this zinc electrode a negative charge. That is why now we are saying our zinc will be our anode, because that is where oxidation will occur. And that is where now electrons will move away as zinc is producing zinc ions and going to the solution. So in short, we are saying zinc electrode is losing electron and forming zinc 2 plus ions. And where are the zinc 2 plus ions going to go? They will go to our electrolyte and changing the concentration of our electrolyte now, meaning that now in our electrolyte, the concentration of Zn2 plus is doing what? It is increasing. So as the concentration of Zn2 plus is increasing, is because the ions from the zinc electrons are going into the solution. Remember, the sulfate ions are still there, but they are not changing. So it means now the electrolyte is having more positive ions and less negative ions. And we say now the side of the zinc electrode, it is now more positive. Then the electrons will move to the side where there is a reduction. And remember, in the reduction side, what we have the copper electrode. And then we have the copper sulfate electrolyte. Inside the copper sulfate, we have Cu2 plus and SO4 2 minus. Just like when we're having Zn2 plus and SO4 2 minus, which is a neutral electrolyte. Now, what happens when the electrons are reaching the side, the two electrons coming from the zinc side? The electrode, which is copper, will not be able to accept those electrons, because remember, it's also a metal. But what it will do, it will transfer the electrons until they reach the non-metallic, the electrolyte, the non-metallic part of the circuit or of the cell. Then these electrons will be now, when you look at the copper sulfate, there are two ions, positive and negative ions. So copper ions, by already, because it has already lost two electrons, seeing the two electrons at the copper electrode, it will just go and accept those copper those electrons and start to form copper around this electrode of copper, making the mass of the copper electrode to increase, because it means now the copper 2 plus ions, after accepting the electrons at the electrode, they form what? Copper solid. And if the solid is formed at the side of the cathode, it is making the size or the size of the cathode to now get bigger, which increases the mass of that electrode. So it means now the copper ions are moving away from the solution. And remember, the copper 2 plus ions are the ones that made the solution to be blue in color. If I can just go back and show you the color of the solution, you see this is a blue solution, and the reason is because of the availability of Cu2 plus. So the Cu2 plus are the ones that are responsible for the blue color. Now, if they are moving away from the solution, it means now at the end, this color will be fading. This will be colorless. So the solution of copper sulfate will be colorless, meaning that the concentration of this solution will do what? Will decrease. What causes the solution of this, the concentration of copper sulfate to decrease is because the copper 2 plus ions are gaining electrons and they are forming what? Copper. So they are moving away from the solution. So what is happening is that the Cu2 plus are moving away from the solution, but the Zn are coming. So it means this side will now be more negative. What made this side to be more negative is because the sulfate ions are still there and they are negatively charged. They're still there inside the solution as the copper ions are moving away. So they are making the two sides not to the electrolyte not to be neutral anymore as the copper 2 plus ions are changing. Now, the salt bridge will now be connected in order to make sure that the two electrolytes do not mix, and also to make sure that the two electrolytes are being neutralized. It provides a electrical neutrality between the two electrolytes. So we normally use salt bridge like potassium nitrate, whereby we know that we have potassium ions and nitrate ions. So you can see that after this cell is starting to operate, the two electrolytes now are starting not to be neutral anymore, as the side of the zinc is becoming more positive, the side of the copper becoming more negative. And that will definitely do what? Will affect the cell potential, which is our V cell, because our V cell potential will start now to decrease. So the formation of the positive ions at the zinc half cell will cause the V cell to decrease, and the using up of the copper 2 plus ions at the site of the reduction will cause the V cell to decrease. So our salt bridge will now come to the rescue of the two half cells and say, you, because we are becoming more positive, I will send my nitrate ions, which are my N ions. So at the site, so the salt bridge will transfer the N ions where the cell becomes positive, and the cation where the cell is now more negative, to try and neutralize that cell. So that will occur until there are no electrons formed anymore. And at that stage, we are saying it means our ions, which are the ions that are accepting the electrons, are being used up, or they are finished from our electrolyte, and we say our battery is flat. When our battery is flat, we say now the cell has reached what? Has reached equilibrium. And when the cell has reached equilibrium is when our V cell is equals to 0 volts. So what happens immediately when you start to connect your circuit? We are having zinc that is losing electrons to give you Zn2 plus 2 electrons. We are having copper 2 plus ions that are aqueous, that are gaining the electrons coming from zinc and giving us what? ZCU solid. So if we write the inert or overall, not inert, overall reaction, we'll find that Zn loses electrons, and those electrons are accepted by Cu2 plus as our oxidizing agent. And Zn, by losing electrons, they will form Zn2 plus, and Cu2 plus, by gaining those electrons, they will form what? Cu. So it means now, as this cell is occurring, the Zn ions and the Cu solid is forming as our product. So what make this V cell to decrease is the increase of the concentration of the Zn and the decrease of the concentration of the Cu2 plus. Now you check in which side are the zinc ions and in which side are the copper 2 plus ions. The copper 2 plus ions are on the side of the reactant, and the zinc 2 plus ions are on the side of the products. So what decreases the cell potential as the cell is in operation? The cell potential will always be decreased by, because this is what I was explaining. So the cell potential will be decreased by, let me just go back. So we are saying the cell potential will be decreased by the decrease in the product ions and the increase in the so these are the product ions. Immediately when the concentration of the product ions increases, then we'll expect our V cell or our cell potential to decrease. So what makes the concentration of Zn2 plus to increase is by the zinc undergoing oxidation reaction and producing those ions. And then immediately when our reactant ions decreases, which is copper 2 plus in this regard, then our V cell will also do what? Will also decrease. So all in all, we are just saying the V cell will decrease as the concentration of the product ions increases and the concentration of the reactant ions decreases until the cell reaches what? Equilibrium, whereby V cell is equals to 0 volts. So the cell potential, so if we want to increase the cell potential, it means we must decrease the product ions and increase the reactant ions, because the reactant ions, remember, they are being needed for them to be gaining those electrons that are coming from that metal or that reducing agent. So if the reactant ions are being used up, then it means the V cell will decrease or the reaction will not occur if they are already being used up and they are finished from the reaction. So it is very important to understand how the salt bridge assists in order for these, as this is the example, as we can see that the Zn ions are forming here and the copper 2 plus ions are moving away from the solution, they are decreasing and they are forming what? Copper. Whereas the Zn is giving out the Zn2 plus. So it means this is the concentration of the ions that will increase and these ions will do what? Will decrease. And that will cause our V cell to do what? To decrease. The salt bridge will try to neutralize by providing the site where there is more positive ions with the negative ions and the site where there is more negative ions with the positive ions. Remember, they are coming from the salt bridge to neutralize the two half cells. And we say the cation ions are moving to the cathode and the N ions are moving to the anode in order for the two half cells to be neutralized. So the function of the salt bridge is to complete the circuit. I think we have seen, because if the salt bridge is not there, this cell will just operate for a few minutes or few seconds and stop. And it is also making sure that the two half cells do not mix and also maintain the electrical neutrality between the electrolytes. So this is what I was explaining to say when the V cell decreases or the cell potential decreases. So the cell potential will decrease if the product ions increases and the reactant ions decreases until our cell potential reaches 0, where we say our battery is flat. So I've already explained how to write our half reactions. It is very important that you know that on the standard reduction potential, the half reactions are given 2 arrows because they can go in both directions depending on what is reacting with what. But when you write half reactions, we will normally start with oxidation half reaction, and then the two half reactions, we balance them to write the overall, but we always use an arrow, a single arrow facing forward to represent each half reaction. I think that was emphasized to you by your teachers, and you don't write it vice versa. That is why when we're writing zinc half cell, we're writing it like this with one arrow, and reduction with like this with one arrow facing forward. It doesn't matter whether it's reduction or oxidation, the arrow is always in one direction to represent the two half cells. And this is the net cell, or we can say is the overall cell, meaning that we have now combined the reduction and oxidation to make one cell. Now, I think we have seen that in the previous example, here we're just trying to show how do we balance the half reactions if the electrons are not equal by making sure that we multiply the electrons in both sides with the other one to make sure that electrons are equal. Then we also need to represent the cells according to the cell notations. So how do we write cell notation? I normally say we write it as A, B, C, which is the anode side, the salt bridge, and the cathode side. So we always start with the anode side, the bridge, and the cathode side. So if we are having a reaction like Zn solid plus Cu2 plus aqueous to give us Zn2 plus aqueous plus Cu solid, we can see that now this is the net reaction. So from the net reaction, we can just go straight to write our cell notation A, B, C. So we know that this one, zinc now, is our anode because it's the electrode that has lost electrons, or it's the electrode that was found where electrons were lost. So it means we're gonna write, we make sure that when you write the cell notation, our solids are at the end or are at the terminals. So it means our aqueous will be in the middle and our solids will be at the end, making sure that they gather or they form the boundaries for those aqueous solutions to react. So it means we're gonna start with the solid, zinc, and then phase boundary, it becomes what? Zn2 plus aqueous, and then we are done with the anode side, and then the salt bridge, Cu2 plus aqueous, and then phase boundary, Cu solid. So you can see that my solids are always at the edges, they are outside the half cells, they are outside, and the bridge separate the two half cells. So we just say zinc forms Zinc2 plus and Cu2 plus form copper. So we are using this single line to separate the faces. If the faces are the same, we just use a comma. For same faces, we use what? We use a comma. Like if we have we have an aqueous and an aqueous, we just use a comma because we cannot say we are separating the faces in that instant. So this is what I was explaining in terms of writing the cell notation. So you need to know how to write a half reaction, which is oxidation and reduction. You need to know how do you write an overall reaction where you combine the two and making sure that the reaction is balanced. And you also need to show how is the cell built up by writing or representing it in terms of the cell notation. Now, when you look at this example here, you can see now that we are provided with two half cells. The examiner will provide you with two half cells. It doesn't matter whether they are starting with oxidation or reduction. When your function or your duty is to always refer to the two half cells by looking at the standard reduction potential, whether the two half cells, which one undergo oxidation and which one undergo reduction. And the reason it is called standard reduction, it is because this cell, it is obtained under standard conditions. The standard conditions will be explained, but you must know that these cell potentials were determined by using the temperature of 25 degrees Celsius, which was common or constant for every half cell that was discovered. The concentration of the electrolytes that they used was 1 mole per decimeter cube. And where there were gases, the pressure was 101.3 kilopascals. So these are the standard conditions that all these cells were determined from. And the reason why they were found by connecting them with the hydrogen half cell, because as you look at your cell potential, you'll find that hydrogen half cell is 0. So let's look at this activity and see whether we can be able to write our oxidation, our reduction, and identify our anode and the cathode, our oxidizing agent and our reducing agent, and the cell notation. So we are provided the iron 2 plus and iron 3 plus half cell, and we are provided a hydrogen half cell. So the first thing that we need to just find out is whether which one undergo oxidation and which one undergo reduction. So we'll definitely go to our reduction potential table, which for my sake is at the back there. Let me try just and go back. So you can see that hydrogen half cell is here and is 0.00. And then if you look at the ion 2 plus and the ion 3 plus, let me just try and clear everything. Yeah. So the hydrogen cell undergoes, okay, let me choose the ink. Hydrogen cell is this one, and the ion 3 plus. So you need to check whether that half cell has all your reactants and all product, because there are lots of ion half cells, but the one that give ion 2 plus and ion 3 plus is this one. So now it means when you compare the two, you'll see that hydrogen half cell will undergo oxidation and this one will undergo reduction. So it means for oxidation, it will be H2 gas, giving us what? 2H plus, which is our aqueous, of course, plus 2 electrons. And then for reduction, we are going to have Fe 3 plus, we write it exactly as it appears, plus electron, giving us Fe 2 plus. Therefore, after identifying the oxidation and the reduction reaction, we can now start and search for our anode and our cathode. When I look at the first half cell of hydrogen, I can see I don't have any electrode because there's no solid that can conduct electricity even here. So in that instant, we need to provide the electrode. For a galvanic cell, we normally provide the inert electrodes as platinum. So we are going to use platinum for both half cells as our electrode, meaning that our platinum will be our anode and our platinum will also be our cathode, because platinum will be able to transfer electrons from one side to the other. What is the function of the inert? Is to just provide the surface of the electron. So it means we are going to use platinum as our anode, and we are also going to use platinum as our cathode for this reaction. So okay, the next thing we need to do, we need to now identify our oxidizing and our reducing agent. To do that, it is very easy when you write the net reaction to say the net reaction is going to be H2 gas, which will lose electrons and give it to Fe 3 plus aqueous to give us what? 2H plus aqueous plus Fe 2 plus. But you can see that the way the electrons are being transferred is not the same. So here it means we multiply by 1, whereas here we multiply by 2. So it means this one will be 2 to balance the half reaction and 2 here. As we are going to balance them, you will see that as we are going to share the electrons, the ions will have 2, 2 because of the number of electrons that will be provided by the hydrogen gas. Therefore, now you can see that your agents will always be your reactants. So it means our H2 will be our reducing agent, and definitely H2 is found at the side of the reducing agent. And our Fe3 plus will be our oxidizing agent in this reaction. And when you look at Fe3 plus, definitely Fe3 plus is at the side of the oxidizing agent. So our cell notation now we need to represent what is it that composes the cell. And we know that we start with our electrodes, or our electrodes will be at the end. So it means our cell notation for this reaction will be platinum solid, and then phase boundary H2 gas, and then phase boundary 2H plus aqueous. This is not the balancing because definitely the half reaction of hydrogen is coming to, and then salt bridge, and then we go to the side of the cathode, we say is Fe3 plus aqueous. Because the phases now are the same, we say comma Fe2 plus aqueous, and then phase boundary platinum solid. So we can see that now in our cell notation here, our phase, our 2 electrodes are represented by platinum because the 2 electrodes didn't have any surface to react on, or we didn't have electrodes in the 2 half cells, therefore we provided platinum as our half cell. So we are trying just to check, okay, let me just go back. We are trying to check how do we represent the cell if there are no electrodes, meaning that now we are going to use what we call inert electrodes. And in our case, we have used platinum as our inert electrode. This was just to assist with the solutions. Now, we are going to also calculate the EMF of these cells. How do you calculate the EMF? We will use the following formulas to calculate the EMF. But when you look at the following formulas, they are also providing you with certain information that you will also need, or you will also need to remember the type of reactions and where do they occur and what is the name of the agent that they occur. So we can just say at the anode, we find reduction reaction and the agent is the reducing agent. At the anode, we find oxidation reaction and the agent is a reducing agent. So this formula can also assist you. So how do we use this formula? Firstly, you need to identify your oxidation reaction and your reduction reaction so that you can see where will the cathode be, where will the anode be. So if we use that one of zinc and copper, you will see that zinc will undergo oxidation. So it means it's going to be E theta cell is equals to E theta cathode. Make sure that you copy your formula exactly as it appears on the formula anode, on the formula sheet, without writing any abbreviation or whatever. So zinc and copper half cell is giving us 0.34 volts, positive 0.3 minus. Zinc, if you can check it on the table, is minus 0.76 volts. Therefore, we are going to find 0.34 volts plus 0.76 volts. And when we add them together, you're going to find 1.1 volts. Make sure that you write the units because this is calculated in volts. This is how we calculate our EMF. So always when you have two half cells, for you to calculate EMF, you'll just definitely use this. And remember, this is calculated under standard conditions. So sometimes the examiner can expect you to know that the concentration is 1 mole per decimeter cube and use that concentration to calculate maybe the number of moles or anything in that. So if we are told that it's under standard condition, there's an information that we are provided, and especially specifically for calculations, we can use the concentration because we know that C is equal to N over V. So they can sometimes give you the volume of a substance and say calculate the number of moles under standard condition. So what the examiner has already provided you, the examiner has already provided you the concentration. So you need not to say, what is the concentration now? You know everything okay under standard condition, whereby the concentration is 1 mole per decimeter cube, which is what I was just explaining now to say this is the information that can be provided to you by the examiner in terms of the standard conditions that these cells operate on. So as we know that these potentials we found using the hydrogen half cell, which is 0.00 volts, and all the values that you see on that standard reduction potential we found by connecting them with the hydrogen half cell and making sure that they use it as a reference electrode to find the potentials of all those cells. Now, when you look at this multiple choice, which is one of the activities that we're just going to do because our time is already running out, you can see that you are given the cell notation, which is the same as the cell notation that we did, the example that you just did now. It's between nitrogen and ion 3 plus to ion 2 plus. So they say which one of the following equation represent the cathode half cell. We know that this is written as ABC, where we expect the anode, bridge, and the cathode side. So if you look at the bridge, it is separating the anode and the cathode. So obviously this one, these two will never be possible answers at the cathode side. So you will look at A and B as your options and see which one definitely will assist you to say which one undergoes or which half reaction takes place at the cathode. If you look at the first one, ion 3 plus gives us ion 2 plus, whereby now our oxidation number decreases. But this one, ion 2 plus, gives us ion 3 plus, and here our oxidation number increases. So definitely the correct answer is number A, because the reduction is when oxidation number decreases. Learners, we have just come to the end of our today's session. I know the time was not sufficient enough to go to many activities, but definitely by understanding what we have been discussing today, you can go to previous question papers and see whether you can try and answer some of the questions that are provided on your galvanic cell. The galvanic cell is question number 8 in our previous in our question papers. So go to question number 8 and see whether you can answer the questions that are asked in that using the same information that is provided to you on this lesson. By so saying, I would like to say thank you so much for watching today's lesson, and make sure that you study for your prelim exam because it's about to be written, and make sure that you have that study timetable that will assist you in order to be assisted in answering these questions on paper 2. From my side, from this broadcasting, I would like to say thank you so much for watching. Until next time, goodbye.